Thank you so much for joining this lesson. We shall be discussing the Homestretch Mathematics Evaluation 2025 September paper, section 1 of paper 2. This is a very serious examination, and if you follow keenly, then you shall discover that nothing is difficult. For every problem, there is a ready solution. So please follow up with us. Remember to subscribe to this platform and also to share the link with your friends. Number 1, solve the equation 2 the logarithm of 2/3 to base 2 equals to a half the log of x to base 2 minus the log of 18 to base 2 plus 4. So we shall be engaging a few laws of logarithms here and there to make sure that we come up with the right answers. So look at this. From the first statement here, we all know that n multiplied by the log of a is the same as the log of a raised to power n. Yeah, n is the power. So with that understanding now, we can apply the law, and that way we shall remain with the log to base 2 of 2/3 raised to power 2 equals to the log, we are applying the same, to base 2 of x power half, which means square root. You're not taking power half, like obtaining square root like that. Then minus the log to base 2 of 18. Then plus 4 to the log of, okay, to reduce much steps, allow me talk about the logarithm of a number to the same base being equivalent to 1. In this question, base 2 has been used, meaning that we can introduce the logarithm of 2 to base 2 where there is a constant 4. So 4, the log of 2 to base 2. You see the log of 2 to base 2 as a value equivalent to 1. Therefore, the value of 4 is not tampered with. Then from this now, we can apply the law here that we were trying to apply and have the log to base 2 of 2 power 4 that way. At this stage, on the right hand side, we can apply the product law and also the division law of logarithms that says when we have the log of a minus the log of b, we should solve this one by taking the log and a over b. And when it is addition, then we need the log a multiplied by b. So applying this on the right hand side, then we shall have the logarithm on the left. Then this is 4 over 9 equals to the logarithm to base 2. The square root of x should be divided by 18, but multiplied by 16. I hope that is 16. Yeah, 2 power 4. It gives us 16 that way. Now that we have applied the logarithm laws, we can now drop logarithms. Then we equate the left to the right hand side. 4 out of 9 equals to the root of x multiplied by 16 over 18, meaning that we can remain with the root of x lax. Here we can remain with the root of x to be equal to, so I take 4 over 9. This should be multiplied by 18 over 16. Yeah, by 18 over 16 to give us then from this, if the square root of x equals to half, then for us to get x now, we should square both sides, and x shall be equal to quarter. So that's how you work out such an interesting question. At number 2, the product of the first 3 terms of a decreasing GP is 64. The sum of the 3 terms of the GP is 14. Determine the first term of the GP. It's good for you to know that. It's very good for you to understand that in a GP, geometric progression, nth term is usually given by a r power n minus 1. So when we talk about the first 3 terms, then it means a, then a r, then a r power 2 as the third term. So the product of the first 3 terms now means a multiplied by a r multiplied by a r squared. Now this gives us 64. At this point, you can see a can be cubed now, and r also cubed equals to 64. You see that, eh? At this point, this is after combining the 3s and also the 3r's. Okay, what if we obtain cube root of both sides? Cube root of 64 is 4. Therefore, we'll be having a r being equal to 4 that way. This is equation 1, and it can still be narrowed down to the value of a being equal to 4 over r that way. Then the second statement is talking about sum. The first term plus the second term plus the third term equals to 14 that way. With this now, we can use substitution. Instead of a, we can use 4 over r because this is equation 1. Okay, equation 2. And from equation 1, we have the expression for a. Therefore, instead of a, 4 over r plus 4 over r multiplied by r plus 4 over r multiplied by r squared. This now gives us 14. That is the substitution. We can proceed, right? And say this, 4 over r from the first term plus 4 plus 4r equals to 14. Why 4r? 4r because this shall cancel to give us r. This shall cancel while the r there is not cancelled. What if we multiply through by the value of r? Or we can do that after grouping terms anyway. So 4 over r plus 4r minus 10 equals to 0. Why minus 10? Because 4 minus 14 becomes negative 10. Yes, that way. Let's multiply through by the value of r. 4 plus 4r squared minus 10r equals to 0. This equation now is quadratic, and we can solve it as 1. There are many methods of solving quadratic equations, very many of them. We can talk of the simplest form here. You see, 4 can be negative on the right. And when it's like that, we can use completing the square method, whereby the first step will be making the coefficient of r squared to be 1. This way, r squared minus, no, we are dividing by 4 throughout for the coefficient of r squared to be 1. So 10 over 4 becomes negative 5 over 2 r equals to negative 1. So we're supposed to add a constant to both sides so as to make the left-hand side a perfect square. So r squared minus 5 over 2r plus a constant, negative 1 also plus a constant. How do we get this constant? The constant that makes an expression a perfect square is usually given by the constant c will be given by the value of b over 2, then squared. So what is the value of b that we have here? Negative 5 over 2. So we divide it by 2, then we square. When you divide by 2, it shall be negative 5 over 4. then we square. So it shall be 25 out of 16. 25 out of 16. Let me use the space below that question. We shall manage the space for number 3. But look at this. We can now factorize. To factorize a perfect square means the square root of the first term, the sign that follows, minus the square root of the last term here, squared, equals to, we have -1 plus 25 over 16. You know, this gives us 9 over 16, right? Then with this, we can talk of obtaining square root from both sides. When you take square root from both sides, you shall be having the value of r minus 5 over 4 equals to plus or minus 3 out of 4. That way. And how will you get the value of r? We can start with the positive value of the square root, 3 over 4 plus 5 over 4, or -3 over 4 plus 5 out of 4. That's all. So now we can get the exact values of r. So this is going to be 8 over 4, which is 2, or 2 out of 4, which is half. So the value of r is, we are getting 2 values, but when we get back to the instructions, we are told that this is a decreasing VP. It means that the value of r is a fraction which is smaller than 1. Therefore, we settle for half because the geometric progression is decreasing. If we apply 2, it will become an increasing GP. So the final answer should be half. Number 3, a question from errors and approximations. The length and width of a rectangular room are given to the nearest 10 centimeters as 18.5 meters and 12.4 meters respectively. Calculate the percentage error in the area of the rectangle. We know very well that the area of a rectangle is given by length times width. But here comes dimensions which have been recorded to the nearest 10 centimeter. In simpler terms, these measurements are in meters. But when we change this accuracy to meters, it will become 0.1 meters. Therefore, the accuracy that has been used in the recording of both the length and the width is 0.1 meters. So we can get the absolute error in the recording of these dimensions. Absolute error is usually given by accuracy divided by 2. Therefore, we take 0.1 out of 2, 0.05 meters. Once you get the absolute error in the recording of the dimensions, we're supposed to identify the limits within which the recordings have been done. Therefore, if its length, then this length is going to lie between, when we have 18.5 plus or minus the absolute error, meaning that this is going to lie from, when we subtract 18.45 up to the maximum value is when we add. So 18.55 meters. Then the width, which has been recorded within the same accuracy, 12.4. We also add and subtract the same absolute error. Then this is going to lie between 12.35 all the way to 12.45 meters. So we have maximum length, maximum width, minimum length, and minimum width. With these dimensions now, we can talk about the maximum area. Area maximum shall be when we use the upper limits of the two dimensions. And this shall be 18.55 multiplied by 12.45. This gives 230.9475 meters squared. We also talk about area minimum. Area minimum is given by the product of the lower limits of both dimensions, 18.45 multiplied by 12.35, and this gives us exactly 227.8575 meters squared. And at the same time, we can find actual area. So actual area will be given by the product of the dimensions as they were recorded. So 18.5 multiplied by 12.4. 18.5 by 12.4 gives us 229.4 square meters. We have maximum area, minimum area, and the actual area. From that now, we can check the absolute value in the computation of the area. Remember, there is absolute area, there is absolute error in the recording of dimensions, and there is absolute error in the computation of area. So we identified absolute error in the dimensions, but now we are talking about absolute error in the calculation of this area. So to proceed, we're supposed to know that absolute error in area is usually given by maximum minus minimum divided by 2. So we take 230.8575, we subtract 227.8575. Something we are not writing well there. 230 is 0.9475. Then we divide by 2. Let me compute it. 230.9475 minus 227.8575. Then we divide by 2. This is going to be 1.545. After that, we can talk about relative error, which is given by absolute error divided by actual area, 229.4. Then after that, we go to percentage error, which is absolute error multiplied by 100. So absolute error should now be multiplied by 100 to give us the percentage error. The final answer is 0.6735% to 4 significant figures. So that is the area computed and the percentage error determined. Now to number 4. These are questions from binomial expressions and expansions. Expand and express 4 minus 4 over 5x plus 1 out of 25 x squared raised to power 2.5 in ascending powers of x, leaving coefficients as fractions in their simplest form. And after that, we use the first 4 terms of the expression in part A to estimate the value of 1.96 raised to power 5. when you look at the power at this point, this is a power 2.5, which is a bit different from what you've been experiencing. So the first case, we're going to expand this expression first. And when you examine the expression very well, this is what we call a perfect square. So how do we factorize a perfect square? We're going to take the square root of the first part, which is a 2, the sign that follows, which is a minus, then the square root of the constant, the square root of this part now, which is going to be 1 out of 5x. And this now is squared. Once you have it squared like that, you notice the equivalence of what? 4 minus 4 over 5x plus 1 out of 25x squared. Then now we can proceed now and say this term, which is to power 2, this is power 2. There is another power here, which is 2.5. 2.5 is the same as 5 over 2. Therefore, this power should be multiplied by 5 out of 2. 2 multiplied by 5 over 2 means that the 2 shall cancel, and we shall have this expression as 2 minus 1 over 5x raised to power 5. So the first assignment was to simplify the expression so that when we multiply by the power which is already existing, we get a power which is an integer like 5. Then after that, we're going to look at the binomial coefficients of power 5. These are values which can be read from the math table. You can access them very easily. They are already in your mathematical 4-figure table. So you don't have to struggle cramming them. You can pick them directly from the 4-figure tables. So I'm going to list them. They start with 1, 5, 10, 10, 5, and 1. So these are the powers. Okay, these are the coefficients of power 5. Remember, every power has its own coefficients. When it is binomial expansion to power 6, the coefficients will be different. Power 7, different. Power 4, different. So now that it is power 5, we list the coefficients of power 5. So now we can start expanding. When we are expanding here, we can start with the first term is at 2. 2 takes power 5, but negative 1 over 5x takes power 0. Then in the next term, 2 descends to power 4 as negative 1 over 5x takes power 1. What you should know is that at every given term, the powers should be adding up to 5. In the first case, we had 5 and 0, giving us a total of 5. Now, in the second case, we are having 4 and 1. We proceed and have 2 taking power 3, negative 1 over 5x taking power 2. After that, we can talk about 2 power 2, negative 1 over 5x power 3. 2 power 1, negative 1 over 5x power 4. And finally, 2 power 0, negative 1 over 5x power 5. So now we can now expand now at this level now. In the first case, we are having, for the first term, which is here, we are having 1 times 2 power 5. You know, 2 power 5 is 32, right? And anything power 0 is 1. So we'll be having 1 times 32 times 1, 32. The next term, 2 power 4, which is 16. So we'll be having 5 times 16 times negative 1 over 5x. It will be having a negative here because 5 will cancel, but the negative will have nothing to cancel it. So this will be 16x. The next one will automatically have a plus. So we are starting with the 10 multiplied by 2 power 3, which is 8. Then now we have negative 1 over 5x being squared. So this will be 10 multiplied by 8 multiplied by, when you square, it will become positive 1 over 25. And that will be 3.2 x raised to power 2 minus the next term, 10 multiplied by 2 power 2, which is 4, right? So 10 times 4, but we multiply by negative 1 out of 5 power 3. 5 power 3 is 125. So I get negative 8, 2 over 5, x power 3. It's my hope that that step is properly multiplied. Yeah, 5 power 3 is 125. Very true. 5 power 4 is 615. So in the next term now, it shall be 5 times 2, because 2 power 1 is just 2. So it will be 5 times 2 multiplied by the positive value of 1 out of 625. And this will give us 2 out of 125 x raised to power 4. Look at that. X raised to power 4. So whenever the power, whenever a term is negative and we raise it to an even power, the negative cancels out. When a term is negative and we raise it to an odd power, like power 3, power 5, the negatives are usually retained. Yeah, the negatives are usually retained. Finally, we have 1 multiplied by 1 again, because 2 power 0 is 1. Then multiplied by negative 1 out of 5x power 5. We shall be negative 1, x is power 5. Then we divide by 5 power 5, which is 3125. So these are fractions in their simplest form, but we should revisit the third term here, which is supposed to be, it was a 10 by 8 times 1 out of 25, giving us 3 and 1 over 5. Should be a fraction. Yeah, should be a fraction that way, not decimal. According to the examiner's instruction, we are told to have ascending powers of x, coefficient of x as fractions in their lowest form, simplest forms, in other words. So we are fully expanded. Now, in the application, we shall be applying up to, we shall be applying up to the fourth term. So use the first 4 terms of the expression. The first 4 terms of the expression to estimate the value of 1.96 power 5. So we first equate 2 minus 1 over 5 x raised to power 5 to 1.96 also power 5. If the powers are the same, then the bases are the same. So we say 2 minus 1 over 5x equals to 1.96. At this point, we can have 2 minus 1.96, giving us 0.04. This is equal to 1 over 5x. It becomes positive. So that the value of x now becomes, we multiply this by 5, 0.2. Yeah, 0.2, like that. X is 0.2. So now applying this in the first 4 terms, we shall have to start with 32 minus 16 into 0.2 plus 3 and 1 over 5 into 0.2 squared minus 8 and 2 over 5 into 0.2 power 3. When we compute all these now, we shall have, when we compute these, we shall have our answer. So we substitute in the calc 32 minus 16, you open 0.2 plus 3.2 into 0.2 squared minus, this is a, this is a 8 point. Let me check so that I write 8 point. I just want to get this value, 2 over 5, 8.4 into 0.2 raised to power 3. This will give us 28 points. 28.8608. Yeah, 28.8608. So that is the expanded form. The most technical bit was up here. This was the most technical bit of this particular question, whereby you are having the power being negative, but it's a relative of 5. Yet part B is also guiding us. It's raised to power 5. So you're supposed to expand until you say 4 minus 4 over 5x plus 1 over 25 x squared. When you expand this, you get the same as 2 minus 1 over 5x squared, because it's a difference of 2 squares squared. Then now, after the squared, we have to multiply it by 5 over 2, because there was an existing power of 5 over 2. Then the expression is now under power 5 that way. And you proceed as an ordinary binomial expansion, a very technical bit. Looking at number 5 now, as we proceed, please be reminded of our schedule here for the August holiday. Kindly feel much invited, you and your friends in senior school and in junior school, for the one-term ahead program from the 20th of November to the 12th of December 2025 via Google Meet. We shall have very interactive sessions covering 2026 term 1 work. The target groups are senior school and junior school. Please feel free to consult using the number which is already attached here, 0704 15 3366. You'll be doing content, coursework. Google Meet is very interactive. You'll be in a position to consult teachers, to answer questions, to ask questions. It will be very fair interaction, just like a normal classroom. Kindly feel free to attend to our programs. Now, to the candidates of 2025 that we have on board, you are much invited to our Sunday mentorship programs, whereby you register through the same number. Yeah, you register through the same number. That is the same number you make inquiries through. And from every 7 to 9 p.m., we have our sessions, very serious, still via Google Meet. Welcome to our interactions. It's a fair one. You can be sure that when you partner with Shifting Grades Online School, you cannot regret. This is the home of academics. 5 on what you call 3-dimensional geometry. We can get through the question. The figure below shows a cuboid labeled A, B, C, D, E, F, G. Point O is the mid of BD, then AB 20 centimeters. AB 20 centimeters. I'm looking at that critically. AB 20, BC 15, BC 15. Then we have a CF S8. CFS8. Okay. Okay. So you will just allow me to doubt the statements there. Then we proceed with the diagram. Allow me to work with the AB as 16, then BC as 12. Let me just use the diagram as it is. When we are taught to calculate the angle between the planes OEF, and OGH. Let me first use my pen here to show you the diagrams. The planes that we are finding the angle between them are these ones. Like that. Sorry. Let me trying to zoom my screen. That is one of the planes. Then that plane is meeting with another one. Meeting with another plane. That. So these are the two planes that are meeting. Now we need the angle between them. And you know very well, for you to find angle between two planes, these are things we've taught, retaught, and I'm going to reteach. Look at these. The planes are meeting at an apex. So at the base where they meet, we can do a straight line. That's where they meet. Then a line through the first plane. So where they are meeting, this way. And a line through the other plane to the point where they are meeting. Yeah, that way. So this is we can let this one be X and Y. Do you know, we just need, technically, we just need the angle X or Y. X, the angle X or Y, that is the angle between the two planes, X or Y. Therefore, let me extract the triangle very well. X or Y. X, Y, and O is here. So we need the angle at this point. That is the angle we need. From X to Y, that is a 16 centimeters. So in case I do a bisection here, then I'll be having 8. Now the vertical height from the mid to O is going to be 6 centimeters. So this is 6 centimeters like that. So how can we get the angle here? We can use tangent and say the tan of the angle alpha equals to, tan is usually given by opposite length over adjacent length to that angle. So the angle here is given by the tan inverse of 8 over 6. Shift tan. 8 over 6 giving us 53.13 degrees. Then the whole angle now will be 2 times now what we've already come up with. This is going to be 106.23. 106.23, like that. 106.23. So that is the angle that we needed between two planes that are meeting at an apex and not along a certain line. So let's distinguish the nature of the meeting of what we are calling now planes, because planes can meet along a line or at an apex, as we have seen in this particular case. Number 6. We're moving very fast. Please remember to subscribe. Remember to share so that you may invite a friend. Remember our consultation line 07 04153366. So these are our consultation line. You can reach out to us anytime for your assistance or for you to get helped. So please reach out through that number. It's also our M-Pesa line, which is active 24/7. Two variables, M and N, are such that M and N are such that M varies partly as N and partly as the square root of N. Given that N equals to 16 when the value of M equals to 500 and N equals to 25 when M equals to 800, find the equation connecting M and N. The first thing that we're supposed to do here is to interpret the first statement from English to mathematics. So let's break it down now to a mathematical statement. M is partly as N and partly as the square root of N. So we say that M is varying as N and partly as the square root of N. Is it square root? Yeah. Some other times you'll be told as the square of N. But now, because of students not reading questions carefully, they will end up seeing square root when it is square and square when it is square root. So let every question be read carefully with every word being underlined. Actually, the critical words like this one, square root of, like that. So from this, we can now break the statement further into M. We introduce an equal sign and two constants. When variation is partial, we usually introduce two constants. So we can introduce a constant K, which multiplies N, and another constant K that shall be multiplying now to square root of N. You see that? Then from this now, we can use the available information to get the values of the constants. N is 16 when M is 500. So 500 equals to K multiplied by 16, get 16K. Then C multiplied by the square root of 16, which is 4. Like that, equation 1. Then again, N is 25 when M is 800. So 800 equals to 25 by K plus C multiplied by the square root of 25, which is 5 multiplied by C. You see now we are already having the two equations. These are the two equations that we shall solve simultaneously for us to get the values of K and C, which are the constants that connect M and N. Simple. So now from equation 1, let me say from 1. From equation 1, we can express the value of C, whereby we can first say that 4C equals to 500 minus 16K. C equals to 500 over 4, we get 125 minus 16 over 4, we get 4K. So now C has been expressed from equation 1, meaning that equation 2 now becomes 800 equals to 25K plus 5 into 1, 25 minus 4K. That way. With this now, we can expand, open the bracket, solve for K. 25K plus this by 5 equals to 625 minus 20, the value of K. So this is 5K. Then we take 800 minus 625 is 175. To remain with the value of K, we divide through by 5. This is 35. So the value of K is 35. What about the value of C? shall be 125 minus 4 into 35. And this gives us the value of C as 125. This is negative 15. When we get negative 15 now, as the value of C, and we are having the general equation here, we make it specific. M equals to K, 35, multiplied by N, then minus 15, which is the value of C, the square root of N. So we have now expressed the equation that connects M and N that way. Yeah, M and N that way. So that is it. We are done with number 6. This paper is interesting, I'm telling you. Please make an appointment with us as we even schedule for the section 2 of the same. Remember also to invite a friend. It's good for you to know that succeeding together is very sweet. There is a great man, that is Martin Luther King, who said that you should learn to live together as brothers or perish together as fools. And we are not fools. So let's succeed together by ensuring that whenever we see a good program like Shifting Grades Online School, we bring on board our friends. Look at the number of our subscribers. How has it grown to that extent? Simply because people have referred their friends to this particular platform. People have grown together. So every year we prepare candidates to pass in their KCSE, and we've been receiving the success stories after every release of national results. So please feel free to invite people. Take it as a personal mandate to invite your friends. Take the success of yourself and that of your friends as a personal responsibility. Simplifying number 7 now. The sine of 60 minus the sine of 45 out of cosine of 60 minus 1, leaving your answer in the form a plus b root c, where a, b, and c are rational numbers, or rather a, b, and c are integers. We're supposed to know that there is what we call trigonometric ratios of special angles. Trigonometric ratios of special angles. Yeah. So in this case now, we're supposed to come up with the unique triangles that usually help us to come up with the trigonometric ratios of these particular special angles. I'm also supposed to tell you, in case you don't memorize the angles, just in case you don't memorize these particular trigonometric ratios for every special angle, 60, 40, 45, and 30. In case you don't memorize them, please memorize the dimensions of these particular triangles where the ratios are extracted from. So we consider a right-angled triangle like this with a length of 2 here, length of 1 here. This is right angle. This is a 16. This is 30. Then this is the root of 3. According to Pythagoras theorem, that becomes the root of 3. Then we also, for 45, we consider isosceles right-angled triangle, whereby we have one unit as the length and height. Then the hypotenuse, if this is 1 and this is 1, it means it's isosceles, so we shall have 45 and 45. And here we will have the square root of 2 automatically as the hypotenuse. So with these two triangles, you shall never lose it whenever trigonometry of special angles is combined with surds. So those are the triangles that I would challenge you to master. Please master those two triangles. Anyway, now we can proceed. The sine of 60 shall be with 60, opposite length of hypotenuse. So the root of 3 out of hypotenuse of 2 minus the sine of 45. Sine 45 means opposite length of 1 out of hypotenuse of 2 divided by the cosine of 60. Cos 60 equals to half 1 over 2 minus 1. That is the substitution that you were supposed to make as the first step. Now, after that, we proceed now to the step of solving this. Allow me start by having the root of 3 over 2 minus 1 over the root of 2. Then this should be divided by negative half. Yeah, negative half. When negative 1 is added to half, we should get negative half. At this point now, you should be able to understand that what we have in this case is a division by negative half. You know, whenever you divide by a fraction, you solve it by multiplying with the reciprocal. So it's like having now the root of 3 over 2 minus half. And instead of dividing by half, we multiply by negative 2. We multiply by negative 2. When you multiply by negative 2, now we open this bracket and have root 3 over 2 multiplied by 2. The 2 shall cancel and give us the negative root of 3. Then we have now negative half. Not negative half, sorry. Inside the bracket, this was root 2, not half. Yeah, negative 1 over root 2 times negative 2. The negative will cancel. It will become a positive, and this will be 2 out of root 2. Remember, this is the same as having it over 1. Yeah, like that. Like having it over 1. So now we can put it under the same LCM. We can put it under the same LCM. Root 2. Root 2 divided by a 1 means the way it is. Root 2 divided by 1 remains the way it is. Then times the negative root of 3. So negative root 6 plus the root of 2 divided by root 2. It becomes 1. So this shall be 2. That shall just be 2. Now this is a surd. It's still a surd. How do you simplify further to make sure that you don't have a surd at the denominator? The surd is not having 2 terms, so we can't talk about conjugate in this case. We just multiply by the same surd both in the numerator and also in the denominator to ensure that at the denominator we don't have any surd. Because whenever you are simplifying surd, the objective is to ensure that the denominator is rationalized. So on the denominator, we shall have the root of 4, which is 2. Then from the numerator, we shall be having negative root of 12 plus 2, the root of 2, like that. So let me simplify the first term. The root of 12 is not in its simplest form because inside 12, there is 4 and 3, and the square root of 4 is known as 2. Yeah, the square root of 4 is known as 2. Therefore, we have negative 2 root 3, negative 2, the root of 3, plus 2, the root of 2, divided by 2. So it means everything is under the division of 2. If everything is being divided by 2, then from the first case, we shall get negative root of 3. And from the second case, we shall get the root of 2, because 2 shall simplify now from both cases. Very simple work and very good work. Interesting for this matter. So it's a very good surd question. Very good surd question. We have simplified it very well. Looking at number 8 now. This is on vectors, position vectors, collinearity, because we are given that The position vectors of points A, B, and C are 2, negative 1, 4, 6, 3, 12, 10, 7, 20. Show that the points A, B, and C are collinear. For you to show collinearity, you're supposed to express two of any vectors that exist amongst the points that are given. You get that? Amongst the points that are given. Then you identify a common point. So let's establish two vectors here. Then we check whether they are parallel to one another. Two vectors can even be a vector AB and vector AC. You can pick any two. It can even be AB and BC. So from this, we can express vector AB by picking B minus A. So B is 6, 3, 12. We subtract A, which is 2, negative 1, 4. This shall be 4, 4, and 8, yeah? 4, 4, 8. What about AC? We need position of C minus the position of A. So 10, 7, 20 minus A is a 2, negative 1, 12. Now this gives us 8, 8, 8, 8, and let me check the value there. No, the position vector of A, this should be 4 and 16, like that. So we have vector AB and vector AC. Now we check a constant multiplying AB, whether it shall give us AC. So we check whether there is a common factor that multiplies one vector to give us the other, so that we may say that they are parallel to one another. So K times 4, 4, 8 equals to 8, 8, 16. You discover that when you use the X component, 4K equals to 8, meaning that the value of K is 2. Now, when you use the Y components, it shall still be 4K equals to 8, the value of K becoming 2. 8K equals to 16, meaning that the value of K is 2. Then now from this, we can say vector, 2 multiplied by vector AB gives us vector AC. If we have discovered that one vector is a scalar multiple of the other, then we can say that the two vectors now, AB is parallel to AC. We identify a common point. Out of the 3 points, which one is appearing in both vectors? A. So A is a common point. A is a common point. Hence, A, B, and C are collinear. Yeah? A, B, and C are collinear. So for points to be collinear, vectors from the points should be parallel to one another. And how do you check that vectors are parallel to one another? By confirming if one of the vectors is a scalar multiple of the other. Number 9, this is on circles, chords, and tangents, you know. We are told that the figure below shows a circle with point A marked on the circumference. As you can see, on the circumference, we have a point A marked there. Using a ruler and a pair of compasses only, construct tangents to cut to the circle at point A. A tangent to the circle at point A. It's a very good question. One thing that you're supposed to know is that in this circle, the center has not been provided. So it is our initiative to first of all obtain the center of the circle. So how shall we get the center of the circle? It's good for you to have some basics about circles and chords. Whenever a chord is bisected, that particular bisector of this chord usually passes through the center of the circle. So if I come up with a random chord, just a random chord like this, it's a random chord. We can even call it PQ. Now, whenever chord PQ is bisected, that bisector will pass through the center of the circle. Therefore, I stand at P, I make an arc, and I also make an arc here. Then I stand at Q and I cut those arcs so that I bisect the chord PQ. So the line that I will produce now, the line that I shall produce as the bisector of the chord will be passing through the center of the circle. This is a bisector of the chord, and it shall eventually pass through the center of the circle. So it means that if I extend it, then I will get a diameter. Yeah. If I extend it like that, I'll get a diameter. Now that I have gotten a diameter, it means bisecting the diameter will give me the center, because the middle point of a diameter is the center of the circle. So now I'm going to use the point here and also the point here to bisect this diameter now. So I stand here, I make arcs on this side and also on this side. Then standing on the other point, I cut the first arcs. Using those arcs, be able to identify the center of this particular circle. So the center can be identified like that. That is the center of the circle, center of the circle. You don't really have to come up with a bisector. This second bisector now, you don't have to. You can just use a straight ruler to connect the two arcs. And when they are connected, you can be led by the ruler. You can be guided very well to mark the center. Remember, the center has been identified now. It's also good for you to know that with a circle here, whose center is unidentified, you can come up with a chord, you bisect the chord, then you also come up with another chord, you bisect the chord. Where the bisectors of the chords meet becomes our center, because both bisectors are passing through the center. So where they meet then becomes the center. So it can be an alternative way of also identifying the center of the circle. Now we are having the center and a point A where we want a chord, not a chord, a tangent to pass through. How do you construct a tangent through a point on a circle? You first connect the center to the point and prolong. So we connect O to A, then we prolong O to A and we prolong a little bit. O to A and we prolong a little bit. Then we construct a perpendicular line through point A. Perpendicular through point A means, let me show you. A perpendicular through A means we stand at A, we make arcs here and here. Then standing on those arcs, now we can make another arc on the upper side and also cut it. We produce now a bisector that passes through A, or a perpendicular that passes through A. This line that passes through A now becomes our tangent. Yeah, that line becomes our tangent. Very simple. So you connect the point on the circle, the point on the circumference to the center, and prolong it slightly. Then after that, now you drop a perpendicular through the point. In our case, it's a point A. So through point A, we drop a perpendicular. As you have seen, that perpendicular now becomes our tangent. The tangent is a line which just touches part of circle without cutting the circle. Just touching. Number 10. This looks a wonderful question. This one must be an interesting item. We shall walk through it together. An object of area 8 centimeters undergoes successive transformations given by P, x1, 3, x plus 3, and T 3101 in that order to give an image of area 168 square centimeters. Find the possible values of x. Find the possible values of x. Look at this. This is a successive transformation. And we are told in that order, meaning that P was performed first, then T. If P was performed first, then we should write them at TP. So this object underwent successive transformation TP. Written in that order, it means P is the one that was performed first, followed by T. So we can write them as now 3, 1, 0, 1. Then the other one is x, 1, 3, x plus 3. With this now, you're supposed to know that whenever we get the product of two matrices in the order in which they were performed, we will get a single matrix that would represent the two successive transformations. So instead of performing E, then T, we can get a single transformation that can represent the two. Therefore, we can get the product of the two matrices. Hence, we would have obtained a single matrix of transformation that would replace the successive transformations. So we can multiply row times column, 3 by x and 1 by 3, giving us 3x plus 3. Next shall be the same row and the next column. So 3 by 1 and 1 multiplied by x and 3, giving us 3 plus x plus 3. That shall be 6. 6 plus x. Yeah, 6 plus x. Like that. Then now on this other side, sorry. On this other side, we will have this row times the same columns, 0 by x and 1 by 3, giving us 3, 0 by 1 and 1 multiplied by x plus 3, making it x plus 3. X plus 3 like that. So this is a single transformation matrix that replaces the successive transformation TP. With this understanding now, we can talk about something else here, whereby we say the determinant of matrix of transformation is usually equivalent to the area scale factor. So once the object is mapped to an image, the area scale factor is equivalent to the determinant of the responsible matrix. The determinant of the responsible matrix. So we will say 3x plus 3 multiplied by x plus 3 minus 3 into 6 plus x equals to area scale factor 168 over 8, which is 21. 168 over 8 area scale factor, which is 21. So we know that a determinant of a matrix is product of elements in the main diagonal minus product of elements in the other diagonal. Like that. So that is it. So let's solve now for x. Let's solve for x. When we multiply these, we shall have 3 multiplying everything in the bracket. So 3x squared, multiplied by 3, we'll have 9x. Then we have 3 by x, giving us we have 9x and 3x, so 12x. Then 3 by 3 shall give us 9, minus 18 minus 3x equals to 21. We can group terms together and have 3x squared. 12 minus 3x gives us positive 9x 9 minus 18 minus 21. So that shall be negative 9 minus 21, giving us negative 30 equals to 0. Yeah, equals to 0. That way. This equation can be simplified. You see, 3 is a common factor. So when you simplify through by 3, it will still be the same equation. So it can be solved at this stage or at a simplified stage when we divide by the common factor 3. So x squared plus 3x minus 10 equals to 0. Then we solve it now. We need a product of AC, negative 10, and a sum, the value at B, which is 3. So we can talk about 5 and negative 2. 5 by negative 2 gives us negative 10. 5 plus negative 2 gives us positive 3. So those are the factors that we need. So we can write x squared plus 5x minus 2x minus 10 equals to 0. From the first two, x is common, x plus 5. Negative 2 is common, x plus 5 equals to 0. So from the brackets, x plus 5, outside the brackets, x minus 2 equals to 0. So with this, then we shall say that the value of x is either negative 5 or x is positive 2, because any of these can be equal to 0. X plus 5 can be 0, giving us negative 5. X minus 2 can be 0, giving us positive 2. So those are the two values of x. This is a very wonderful set. Okay, there can be an alternative working anyway. There can be some alternative working. Let me think about it, then I just wrap the space here. It's good I explore the other type of working. So I'll clear up the space here so that I may take you through the alternative working. Look at number 10 once again. The object is transformed first by matrix P, later by matrix T. So we can get the two determinants multiplied. Determinant 1 times determinant 2. So det 1 times det 2 to give us the area scale factor of the final image. What is the first determinant? The first determinant shall be, x multiplied by x plus 3 minus 3 multiplied by 1. I'm using leading diagonal product of other elements. So this can simplify to x squared plus 3x minus 3 that way. What about the second determinant? This is det 1 from the first matrix. Determinant 2 shall be 3 by 1 minus 0 by 1. So it shall be 3 this way. 3 by 1, 0 by 1. So now we are having 3 as the second determinant. So the product of these determinants, determinant 1 and determinant 2 multiplied, should give us the area scale factor, which is 21. Say 3x, or instead of expanding, we can divide through by 3. Yeah, to remain with x squared plus 3x minus 3 equals to 7. X squared plus 3x minus 10 equals to 0. We are back to the equation that we were solving. So you will proceed and get the same questions. So determinant 1 times determinant 2 will give us area scale factor when we consider the final image and the objects. Alternatively, you can follow the skill about successive transformations, because we've been learning it in shifting grades time and again. Yeah, we've been quoting successive transformations here and there. It's good you get used to the same. number 11. In a mathematics test, the scores obtained by 40 students were recorded as shown in the table below. We have the scores, then we have the number of students. Find the exact mean absolute deviation. First, we're supposed to find mean. We find mean. What is the mean? The mean shall be 2 students, each with 50, 5 students, each with 55, 8 students, each with 60, 10 students, each with 65, 7 students, each with 70, 5 students, each with 75, 2 students, each with 80, sorry for that. 2 each with 80, then 1 with 85. So 85 times 1. Then after that, we divide now. This will be the total marks. We divide by the number of these students, which is 40, to get the mean. Let's get mean first. Yeah, we get mean first. So 2 into 15 plus 5 into 55 plus 8 into 60 plus 10 into 65 plus 7 into 70 plus 5 into 75 plus 2 into 80 and then plus 85. I'm getting 15 out of 40 students. So when I divide these, I'm getting a 65.375. I'm assuming that is the right mean. I'm assuming this is the correct mean. You can also work it out there. Please compare your value with mine. In case I compute wrongly at any given point, kindly take the concept. Kindly take the concept and ignore the error. Yeah. Take the concept, ignore the error. So that's the mean. Let's now check how each mean varies from every deviation. So we'll be getting deviations now, whereby we need each value minus the mean. Each value minus mean. So now, in the first case, it shall be 50 minus, we get negative 15.375. The next shall be 55 minus 65.375, get negative 10.375, comma, 60 minus 65.375, giving us negative 5.375. The next shall be after 60, 65 minus 5.375, I'm getting negative 0.375, comma, 70 minus 65.375, giving us 4.625, comma, that's after 70, 75 minus 65.375, this giving us 9.625. That's after 75. So we go to 80, comma, 80 minus 65.375, giving us 14.625, comma, then 85 minus 65.375, this is 19.625. Those are the deviations. You know, for you to get mean absolute deviation, you get the mean of all absolute deviations. Mean of absolute deviations. So we'll be taking summation of absolute deviations, and we divide by the number of students. So in this case now, I'll be taking absolute deviations. So 15 point, absolute means you ignore the sign now. 15.375. How many students are having that deviation? 2 of them. So it will be 30.75 plus 10.375 times 5 students are having that. 51.875 plus, in the next, we have 8 students with a deviation of 5.375, giving us exactly 43 plus a deviation of 0.375 times 10. Yeah, times 10 to give us 3.75. I hope that is where we are. The next one is, I've multiplied that by 10. So the next shall be a deviation of 4.625 multiplied by 7. That gives us 32.375 plus a deviation of 9.625. This should multiply 5. So this is 48.125 plus a deviation of 14.625. This one times 2 students, which is 29.25. 29.25. Then I add, go to the last deviation of 19.625. We have only 1 student with that. So after adding everything now, we shall divide by 40. So we can slowly compute the addition. 30 point. Yeah. We compute the additions. We compute the additions. I think I should confirm this. Yeah. Let me confirm. 30.75. I add 51.875. Then I add 43. Then I add 3.75. Then I add 32.375. Then I add 48.125. Then I add 29.25. Then I add 19.625. So I'm getting a 258.75 out of 40. So when I divide by 40, I'll get 6.46875. So this is the mean absolute deviation. Mean absolute deviation. Very simple. Mean absolute deviation. That way. Now look at number 12. The figure below, or the figure PQRS below, is a scale drawing representing a garden in the shape of a parallelogram of length 80 by 50. Yeah, you can see. Then from that, we are told that the owner intends to plant maize in the garden. Each maize must be at least 25 meters from Q. In addition, each maize must be nearer QR than PS. QR than PS. This is a Loci now, and we're supposed to interpret instructions so carefully. Show by shading the exact region where the maize can be planted. So this maize is going to be at least 25 meters from Q, at least 25. So 25 meters and beyond. When you stand at Q, maize should be 25 meters and beyond, meaning that we shall use an arc length. We stand at Q using an arc length of 5, yeah, according to the scale which has been used. An arc length of 5, yeah, an arc length of 5, then you draw. So stand at Q, you do an arc length of 5. Using 5 meters, or 25, sorry. Yeah, we use 25 meters. According to the scale, you will know the appropriate length there. I'm using a complete length because it is at least 25. Could be 25 or beyond. If in case you'd been told should be more than 25, we would have used strictly 25 and we dot it to show that it is beyond that. But now a complete line indicates that it can be at 25. Now the next thing is talking about being nearer QR than PS. PS is here. QR is here. So exactly between PS and QR, then we should be near QR. Near QR, meaning that the side with PS is unwanted. So how do we identify the mid of PS and QR? And this is a parallelogram. You can't draw a perpendicular line. So you're just supposed to measure the mid of SR, or you stand here, you construct a bisector. You bisect, you bisect, sorry, I'm waiting for the screen to settle. You bisect QS. Sorry. Trying to manage the screen, like that. So you identify the mid of SR, and you also identify the mid of PQ. Standing at P, you make X. Standing at Q, you cut the X, like that. You also identify the mid of PQ. Once the mid of PQ and SR have been identified, now you can do a line. Now this maze is supposed to be landed closer to QR than PS. So it should be on this side. Remember, it should be beyond 25 from Q. Beyond 25 from Q. So this is the area now where maize shall be planted. So maize is going to be within that region. All of that region is maize. So that's how you interpret the question on Loci. A very simple question. Find the exact area enclosed by the curve y equals to x squared minus 2x minus 3 and the x-axis. Now, if a curve is enclosing area with the x-axis, then it means we just have to identify the behavior of the curve around the x-axis. And this means, you know that when a curve is drawn, it usually cuts the x-axis at some points. And we know very well that the points where the curve is cutting x-axis becomes the solution of this particular, it becomes the solution of the particular equation. Therefore, we're going to equate this function to 0 so that we treat it as quadratic. We solve for the values of x. Once the values of x have been solved, listen to that. Once the values of x have been solved or found, then it means those are the points where the curve is cutting the x-axis. Then now we'll be able to know how to integrate. So here we shall equate x squared minus 2x minus 3 to 0. Product AC sorry, -3, sum -2. These terms now are going to be -3 and 1. Okay, yeah, -3 and 1. Product -3, sum -2. So x squared minus 3x, then plus x minus 3 equals to 0. So we can factorize x to remain with x minus 3, then 1 to remain with x minus 3 equals to 0. So now from these, we can say that x minus 3 and x plus 1 equal to 0, meaning that x is 3 or x is -1. You see now, we have the two values of x. This curve cuts the x-axis. This curve cuts the x-axis at -1 and also +3, meaning that for us to get area between the x-axis and this particular curve, then we need to integrate from -1 to 3, x squared minus 2x minus 3 with respect to x. So this is called a definite integral. Are we coming? So let's integrate now from -1 all the way to +3. This way, we integrate the first term, which is x squared. So it becomes x power 3, and the 3 has to divide minus. This is a -2x. X becomes power 2, and the 2 divides. Now I'm integrating this, whereby it is -2, x becomes squared, and the new power has to divide everything, making this one just a -1, x squared minus 3, x is reintroduced, arbitrary constant from -1 to 3. With this now, we can substitute the limits. We begin by 3, which is now 3 power 3 over 3 minus 3 squared minus 3 into 3 plus c, then minus -1 power 3 out of 3 minus -1 squared minus 3 into -1 plus c, like that. So we can compute the first part, the second part, and we subtract. Now from the first part, okay, let me use my calculator very well. I must use the calculator very well in this case. 3 power 3 is 27 over 3, giving us 9, minus 9, and minus 9 once again. So I'm getting -9 at the end of it. Then after that, we have to subtract the other part. Now the other part shall be, what we have here is a -1/3. Minus -1 squared minus 3 into -1. Now this, okay, this is giving a different value. But you have to be patient with my substitution. -1 cubed becomes -1. We divide it by 3 like that. Then we subtract -1 squared. We subtract 3 into -1. So I'm getting a 1.66, which is the 1 2/3. Like that. So this should be -10 2/3. Now that it is negative, it only shows us where the area is found. Whenever area is negative, it means it is on the lower side of the x-axis. So for you to get the exact area, it should be now 10 2/3 square units. You take the absolute value of the negatives after the integration. Number 14. Juma deposited 54,000 Kenya shillings in a financial institution that paid simple interest at the rate of 14% per annum. Mark deposited the same amount of money as Juma in another financial institution that paid compound interest at the rate of R% per annum, compounded semi-annually. Look at that. Compounded semi-annually. After 6 years, they add equal amounts of money in the financial institutions. Find the value of R to 2 decimal places. Therefore, the first case of Juma, we can get the amount Juma is having. So Juma's amount shall be given the principal, 54,000, plus the simple interest. The simple interest. And simple interest is given by principal times rate, which is 14% times the number of years. You know, they're going to do it for 6 years. So now from here, we will know the amount, the total amount that will be in Juma's account. So we talk about 54,000 multiplied by 14 over 100. Then we multiply by 6. The interest shall be 45,000. So we have the principal plus the interest which has been earned. The interest earned is going to be 45,360. So it shall be, we add 54,000. This is 99,360. So this is the amount of money which will be in the account of Juma. We are being told that after 6 years, Mark is also having the same amount, but he had a different deal. Very different deal. Therefore, we will say, amount is usually given by principal into 1 plus rate raised to n. Therefore, he is going to have the same amount, 99,360 equals to principal. He invested the same amount, 1 plus a known rate over 100 raised to the number of interest period after 6 years, but compound interest is being done semi-annually, which means within 6 years, we will have 12 interest periods. So this amount should be divided by 54,000 first. This gives me 1.84 equals to 1. I've divided through by 54,000. R over 100 raised by 12, or raised to power 12. We continue solving for the value of R. We obtain the 12th root. So 12 shift power of this answer. I'm getting 1.052127 equals to 1 plus R over 100. So to subtract 1 from both sides, we shall have 0.5, 0.52127 equals to R over 100. Now shall you remain with R multiplied by 100. This will be 5.2127 to 2 decimal places now, 5.21%. Yeah, that is the rate. 5.21%. 2 decimal places. 2 decimal places. But it's also good for you to know something. R, the rates are per annum. So this is the rate which was used in the semi-annuals. That's a long con. The interest that was applied in the semi-annuals, the interest that was applied in the semi-annuals is 5.2127, meaning that we can get the interest now per annum. So this is per semi-annual. So per annum shall be 5.21 times 2. Let me multiply the original value by 2. It shall be 10.43. 10.43. So we should round off to 2 decimal place the original value. So I should multiply by 2 at this stage. Yeah, multiply by 2 at that stage. Look at number 15. Very interesting question. Very interesting question. I'm sorry. The screen is a bit misbehaving because of overuse, but it's stabilizing. And we are also almost through. In number 15, the arc below is part of a circle passing through points P, Q, and R, just as you can see. Determine the center and radius of the circle. We start by determining the center. One thing that we are sure about is that as we did in one of the questions where we were constructing a tangent, I hope you remember that question. When we were constructing a tangent, we said whenever a chord is bisected, it shall pass through the center of the circle. So a chord PQ bisected shall pass through the center of the circle. So when I bisect this one now, I'll pass through the center of the circle. When I take the other chord, QR, and I also bisect QR, I will also pass through the center of the circle. Therefore, this becomes the center of the circle. So we can get coordinates of C. That is one concept that I have applied. You can even use the vectors concepts. Yeah, vectors concepts can also be used here, and you shall get the same answers. But let's now embark on the first analysis that I'm coming up with. Chords bisected, the bisectors usually pass through the center. I hope we are together in that statement first. Any chord, when bisected, the bisector passes through the center. So we can get the equations of these bisectors. Equations of these bisectors by first saying that equation of PQ, let's get not equation but gradient of PQ shall be 3 minus 1 out of -2 minus -2, giving us 2 over 0. Let's stay with the gradient like that. So the bisector, which we can call it a bisector 1. Now, bisector 1 will have a gradient of, remember, we've bisected the PQ, meaning that they are perpendicular to one another. Therefore, the second gradient, when multiplied by 2 out of 0, we're supposed to get -1. So this second gradient now shall be -1 by 0 over 2, giving us 0. So we have a line whose gradient is 0. So the line has a gradient of 0, and where it means perfectly a horizontal line. A horizontal line. So if that is an horizontal line, we can check the value of x at that particular line. Yeah. So now, what is the point where this perpendicular is passing? The perpendicular B1 is passing through the mid of PQ. So mid of PQ, then we call it mid 1. Mid of PQ shall be -2 plus -2 over 0. 3 plus 1 over 2. Sorry, over 2. Sorry, this is over 2. So this shall be -2 plus -2, get -4 over 2. negative 2. Then 2 over 2, we get 1. 4 over 2, we get 2, sorry. 4 over 2, we get 2. So this line has a gradient of 0, and it passes through negative 2, 2, meaning that the equation is in the form y equals to 2. It doesn't have a gradient. Y equals to 2. That is the line. So along B1, y is 2. What about B2 here? You have a line bisector 2. The bisector 2 of QR will have a, let's get gradient of QR. So QR gradient shall be 1 minus negative 1 out of minus 2 minus 0. Minus 2, negative 0. You know, this will give us a 2 over negative 2. 1 minus negative 1, 2. Minus 2 minus 0. We get negative 2. So negative 1 is the first gradient, meaning that the gradient of B2 will be 1. The gradient of B2 is 1. And where is B2 passing through? Midpoint 2. The midpoint 2, where B2 passes, shall be the midpoint of QR, which is negative 2 plus 0 over 2. Then 1 plus negative 1 over 2. So gradient, okay, midpoint 2 shall be negative 1, comma. This is 0 over 2, which is just 0. Yeah. So this is where the line passes. Can we get its equation? 1 equals to change in 1, change in x. Y equals to x minus 1. This is now the second line. We have line 1 and line 2 is here. This is line 2. So we can now say that the value of x can be found, because where these two lines meet, y equals to 2. If y equals to 2, then x can also be found. X shall be equal to 3. So the coordinate of the center of the circle shall be 3, 2. If we have the center of the circle, it will now be very easy for us to find the radius. The radius of the circle now requires a vector length now. From P to the center, from Q to the center, from R to the center, any. So radius shall be the magnitude of PC. So let's get PC first. C minus P, giving us a 3, 2, minus C. That is C minus P, which is negative 2, 3. So this is 5, negative 1. So the radius shall be 5 squared plus negative 1, also squared, the square root. So R shall be the square root of 26. That's enough. If you're given a given number of square units, a given number of decimal places, significant figures, or any other specified accuracy, the radius shall be 5.099. Yeah, that way, and that's simple. That way, and that's simple. A very good question. Number 16, which is the last in section 1, but you should be ready for the section 2 of this paper, which will be streaming anytime. Remember to subscribe just for our updates. Please be a subscribed member. Remember to consult through 0704 153366. Just purpose to follow us through our numbers You can reach out through our TikTok account, Shifting Grades. Now we are told that a cup of hot tea is left to cool in a room. The table below shows its temperature T in degrees Celsius at different times, T in minutes after being placed on the table. So we have a table there for everything. Then we're taught to plot the graph of temperature T against time. When it is a temperature against time, it means that the quantity mentioned first lies on the vertical axis. That one is a basic which is supposed to be understood. When we are plotting a quantity against another one, the quantity mentioned first usually lies on the vertical axis. So we shall have our temperature on the vertical axis, then time in minutes on the x. Yeah, time in minutes on the x. So time in minutes shall be there, but temperature in degrees Celsius shall be on the vertical axis. Time is 0 all the way to 25. So we can use intervals of we can use intervals of 5 from 0, 5, 10, 20, 30, 40, like that. So we can use intervals like these ones. Then after this, I hope, I don't know whether I've used the right scale. Sorry for that mistake. Sorry for that oversight. You know, from 5 to 10, then you should go to 15, then to 20, then to 25, then to 30, like that. Yeah, that's how it should be. A scale should be uniform, in other words, and accommodative. All right, on the vertical axis, we can use intervals of 10 all the way to 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We have the scale properly marked. Now let's look at the coordinates now. 0, 95. It was already at 95 before the cooling began. Then after 5 seconds, it was at 57.2. 57.2, this is 50, 52, 54, 56, 58. So just before that, we'll have our coordinate there. At 10, 38.5. At 10, 38.5. So we can talk about 38, just below 40. At 15, 29.2. At 15, 29.2. Just below 30. At 20, 24.6. At 20, 24.6. So this is a 20, 22, 24. So 0.6 should be in between there. And at 25, we have 22.3. So at 25, we talk about 22.3. So 20, 22 point something, just there. So that's how the points are supposed to feature on this particular graph. We can join them using a very smooth curve. You know, there's a coordinate we didn't place in the right place. There's a coordinate which was misplaced. After 5, we went to 57 point something. So after 5, 57 point something. So this is where the coordinate should be here, like that. Let me do the curve now. I'm using a very, very smooth curve. Like that, a very smooth curve. So we are having the curve now, the graph of temperature against time. Let me restore my vertical axis because I can see it has been cleared accidentally here like that. So this is the graph. That is the graph. Then we are also told to use the graph to estimate the rate of change between t equals to 3.5 and 8.5. So 3.5 will be accompanied by some temperature. Then 8.5 shall also be accompanied by some temperature. So those are the temperatures that I want us to read from this particular curve at 3.5, at 3.5. This is 0. This is 1, 2, 3, 4, 5. So 3.5 will be identified just after 3 and before 4. So you can check the temperature there, which is according to me 68. 68. Then 8.5, we also check the temperature there. 8.5, this is a 5, 6, 7, 8, 9. Just before 9, you look at the value there. 8.5 is just before 9. So we check this value, which is proving to be 42 for my case. Yeah, 42 for my case. Let's look at the rate of change. We need a gradient now for rate of change. So 68 minus 42 out of 3.5 minus 8.5. So 68. When I subtract 42, I'm getting 26. Now 3.5, when I subtract 8.5, I'm getting -5. So the rate of change is going to be 5.2 or -5.2. This is the rate of change within the time limits which have been provided. Thank you so much for following. Remember to subscribe to our channel. Remember to share so that you may invite a friend. Thank you.